Okay, so today's lesson, okay, again, common chord is G for geometry, CO for congruence, and it is number 10, which is basically proving theorems about triangles. And the date is Pi Day 3/14, and if you're absent, I'm sorry, because we're all enjoying Pi. Just have to put that on film. So when Sully watches this day, she goes, I missed out on Pi. Or Megan. So, the in-center. So I've got the picture. I'll draw it, but if you think about the word in-center, the circle is really on the inside. That's why it's called the in-center. The point, this is the point P is going to be the in-center. P is the in-center. So how do we get it? We get it with angle bisectors. So I already did this, but I'll real briefly go through again what I did. To do an angle bisector, you go so you got to get these two little dashes here, and then you put your compass on that point, you do and you get a little point of intersection here, and you draw from A to that, okay, and that makes a angle bisector. So I do know something else that's kind of important. Hey, I know that this angle here is equal to that angle here. It has to be because it's an angle bisector, right? Yep. And then I did the same thing on angle C. I went and then I went got my little point of intersection here and drew in my lines there, my ray, and then of course then what I have again is an angle bisector, so I can say that, hey, you know, this angle here has to be equal to that angle there. And then finally I did the same thing with B. I did my little and then I took my compass and did little sound effects there. I drew in from B to that point of intersection right there. Now all three of them intersected in a single point P, and that single point P made by all the angle bisectors. That's my in-center, okay? So my in-center is created by all of the angle bisectors. Since it's an angle bisector, then of course, you know, that angle's got to be equal to that angle, right? Okay, now, when you get the in-center, then what you do is you change your compass, and I'm going to try and draw the circle. I have to really make my compass smaller to make this fit. Make the compass smaller so it just fits. So I want it to barely touch these sides because I need this circle to be on the inside. So do a circle, draw it, draw it, draw it, draw it, draw it. So it's called an in-center because the circle's on the inside, okay? Now one of the things is when I drew my circle around, it just barely touched the triangle here, barely touched the triangle here, and barely touched the triangle here, okay? Those are called tangent lines, all right? So then I'm going to draw from P to that point. So it's the shortest distance, isn't it? Think about it. It's the shortest distance, shortest distance, shortest distance. And because of that, they're also perpendicular. Now, obviously, if all three of these blue lines are radius of the circle, same circle, then they have to be equal, okay? So I do know that PY's got to be equal to PZ, which has got to be equal to PX, and that's what our theorem says these are equal, okay? And it makes really obvious sense once we draw in the circle. It's got to be equal, okay? Now, so what do we know? Properties. We know that our line segments, which are the radii of the circle, all three radii of the circle have to be equal. We also know that they're perpendicular, and nothing else I need to put on here is we also have angle bisectors, right? So we have angle bisectors, right? Bisectors. So I know that that angle is equal to that angle is equal to that angle, and that angle is equal to that angle, okay? Thumbs up. I see a couple thumbs up. Okay, all right. Turn the page. So then, now, here we have, so if I'm told angle bisectors, right? So then if this is an angle bisector, and this is an angle bisector, then we could draw on the third angle bisector, and we don't need to, but we could draw on the third angle bisector, which is right about there. I might draw it in anyway. Okay, you don't need to, but I might draw on the third angle bisector. Maybe right about there. It has to intersect in that point right there. So V, point V is my in-center. So V is the in-center. Has to be because it was created by angle bisectors, right? So then what do I know? Well, angle bisectors. Well, okay, let's go back right here. If this is 19 degrees, that has to be 19 degrees. You guys agree with that? If I want to find angle K, I know that within a triangle there's 180 degrees for the interior angles, right? So to find angle K, I'm going to go 180 and I'm going to subtract, you ready? 38 and subtract 106. And I said 38 because 19 and 19, right? So let's find out what angle K is. Calculator time. So I'm just going to do a little bit of work here. Let's see, 180. 180 minus 38, subtract 126. So I get 16 degrees. So that's for angle K, which means this would have to be 8 degrees and 8 degrees apiece, right? Okay with that? So solve the triangle. We basically have, there's a few other little things I can put on here. If this is 7.3, I could put in another one of those, right? That would also be 7.3, right? And this would also be 7.3 at 90 and 90, okay? And that's it. Not too bad. So homework today, and again, I need you to show your work, draw the pictures, show your work, page 311, 7, 9, 10, 18, 19, 48 through 50, okay? How's that? And where's my little button to stop recording? There it is. And we're